Lesson 51, Simplifying Rational Expressions with Like Denominators. One thing to remember is the denominator of any fraction cannot equal 0. So those values of the variable that would make the denominator equal to 0 are called excluded values. So I'm going to give an example where we need to find the excluded values. And the way we do that is we take the denominator, which is c minus 6, we set it equal to 0. Well, we say that it can't be equal to 0. Then we solve it using inverse operations. We're going to add 6. C cannot be 6. And the excluded value is 6, or C cannot be 6. How about this one? If we had 9 over 4h. Here's another example. We would take our denominator 4h and say, well, that can't equal 0. By inverse operations, we're going to divide by 4, so h cannot equal 0. 0 divided by any number is 0. So if we are adding two fractions that have the same denominator, for example 1/3 plus 1/3, we keep the denominator the same and add the numerators. Now sometimes we have denominators that have variables in the denominators. So here's an example where we have variables in the denominator. So when we solve this, we keep the denominator the same, and we write b minus 2b in the numerator, which is b minus 2b is a negative b, and then we have to look at all the denominators through a whole problem, and they're all a, so we write with our answer, a cannot equal 0. So when we are simplifying rational expressions, and that's expressions with variables in the denominators, we have to list the excluded values. So I want to do another example here. We have p times q to the negative 2 minus 7 divided by p to the negative 1 times q squared in the denominator. So I'm going to rewrite it so the negative exponents are in the other part of the fraction. So q to the negative 2 is the same thing as q squared in the denominator. Then on the second term, p to the negative 1, that's in the denominator, will become p in the numerator. Because it's negative, we bring it up. So now they have a common denominator, which is q squared, and p minus 7p is negative 6p. Then we look at all of our denominators. Through all of our work, we have p's and q's. So we need to write p and q cannot equal 0, and that would be our answer. Let's see, do I want to do another example? Okay. We have d m to the negative 2 divided by 3 plus 5d divided by m squared. So we're going to rewrite it with the m to the negative 2 in the denominator. So we have d 3m squared plus 5d divided by m squared. Now we need to get a common denominator. The factors of this one are 3 times m times m. The factors of this one is just m times m. So we need to get 3 and two m's in our denominator. The first one has that, the first term. The second term we have to multiply by 3 over 3. We're multiplying. So we have d plus 15d, which is 16d, all divided by 3m squared. When we can't cancel or reduce, the only denominators that we have are m, so we can say m cannot equal 0. That's the end of the lesson.